Okay, hello folks. This is our second lesson in the Introduction to Quadratics unit. You don't really know much about what quadratics are at this point, and in this lesson I essentially am going to tell you what quadratics are, what the graphs look like, and what the different parts of the graphs are. It should be a pretty easy lesson. I'm hoping the first lesson was pretty easy. You're probably noticing this stuff doesn't take a ton of time. I am paring stuff down a lot to make it hopefully easy enough for people to do on their own. So this is Tuesday's lesson. It should pop up at Tuesday at 8 a.m. If you have questions or anything, please don't hesitate to email me. I can give you a call. We can do a video chat or whatever works for you. Okay, so here's our schedule for the day. I'll be able to identify the features of quadratic functions. Now, what I would like to do first is to give you a first 5-minute question, and this is going to be based on yesterday's stuff. So I would like you to determine the first and second differences of the data that will be in this table in just a moment. I'm going to pause and put the data in. Okay, so I have put in the data here. So what I would like you to do, you're going to have to write this on separate paper, unfortunately. This is like that first 5-minute question that we usually do. And I would like you, using the information from yesterday, to determine the first differences and the second differences. I would really like you to try to pause and try this question on your own. So please pause now. Okay, so I'm going to go ahead and do it now. Now the only difference here from yesterday really is that you're not going to have a nice table here for you, and I'm going to show you what that looks like. So to do the first differences, first we're going from 9 to 4. So that's going to be 4 minus 9, and that's going to be negative 5. And you can pause at any time. If you're like, oh, I remember now, just pause it, give it a shot. This is going to be 0 minus 4 is negative 4. From 0 to negative 3, that's going to be negative 3 minus 0 is negative 3. And use a calculator, use it on your phone, whatever works. Remember, we always do the bottom number, so negative 5 minus the number above, and if it's negative, I put it in brackets. Negative 2. You can probably see a pattern developing, but just do it manually, just in case, because sometimes I might put one in that's a little bit different just to trick you. So negative 6 minus minus 5 is going to be negative 1. So there's the first differences. They're all different, so we know it's not linear. Now we're going to do the second differences. So same idea as yesterday, so negative 4 minus negative 5, and that's going to be 1. Negative 3 minus negative 4 is going to be 1 again. Now you're probably like, oh, they're all going to be 1. But just do it anyway, just to make sure, because you never know when I'm going to mess with you. Negative 1 minus minus 2 is 1. Okay, so all the second differences are the same. Hopefully from yesterday you remember that if all the second differences are constant or the same, that means that we are dealing with a quadratic. Okay, so it is quadratic. That's the opening question. Now we're going to jump into today's stuff. You can pause, rewind, whatever. Just try to make sure you can do this. If you can do this, you're good to go so far this unit. All right, so here is your first parabola. Now normally in class we would have done a whole thing where you're drawing parabolas by now, but because things are a little bit tricky with everybody being at home and not having technology or not having paper or whatever, not having graphs is the big one, I'm going to just sort of go through this with you, and things will be a bit different than they would have been in class. So these are the key features of a parabola. These are your unit terms, and they're really, really important. And if you work through this lesson with me and then do the practice, I think you should be okay. So first of all, you'll notice that this is not a straight line. I should put little arrows on these. My graphing program doesn't do that automatically. But those arrows mean that this goes up forever. And you'll notice if you start down here at this point, which is called the vertex, okay, that's the vertex, you should notice that it goes up to the right and up to the left. So very different than a line. You should also notice that as it goes up, it actually starts to go faster and faster and faster. And it will keep going faster as long as you're going up. Okay, so that's the vertex. Now the min-max value, so let's label the vertex first. So every point gets an x and a y. So the x value of the vertex, I go up to the x-axis, is negative 2. And the y value, I go over here, and it's -9. Okay, now, that's the vertex. Probably the most important thing from today, I would say. Now the max-min value, that's going to tell us whether this parabola has a maximum or a minimum value, and what that maximum and minimum value is. Well, we can see that this goes up forever, so there is no max. However, if we're moving down, eventually we'll get to the lowest point. And in this case, the minimum value is down here. The minimum is going to be the y value, and that's going to be right here. Okay. So the minimum value is y equals -9. Okay, and if you're having trouble keeping up, I'm going to do 2 full examples still, so there's lots of time to figure it out. Now the axis of symmetry, when you hear the word symmetry, you should think about a mirror or think about something that's the same on both sides. An axis is just a line, right? We have the x-axis and the y-axis, and now we have what's called the axis of symmetry. And the axis of symmetry basically tells us where would I put a mirror on this thing to make it so that it's the same on both sides. And that mirror would go right through the vertex. And we'd have to define that axis. It tells us the x value of the vertex. And so the axis of symmetry is x equals -2. Okay, and again, I'm going to do a few more examples, so don't panic if you're falling behind. You can always pause and rewind. The y-intercept is the same as it's always been. The y-intercept tells us where the graph crosses the y-axis. This is the y-axis, where my mouse is. Hopefully you can see that. And you can see right here, the graph crosses the y-axis. And so our y-intercept is right there. And for us, it's going to be y equals -8. Or, because it's a point, you could say 0, -8. Okay, so there's the y-intercept. Now the x-intercepts. You may be able to guess this on your own. The x-intercepts are where it crosses the x-axis. So we can see that it happens here, and it also happens here. So that's an x-intercept, and that's an x-intercept over here. Now the way that we would write those is here we could say x equals -8, and here we could say x equals 4. I'm understanding and guessing that that's probably going to be hard for you to read, so I will make those, I'll just make them red. And I'll avoid using yellow moving forward. In the classroom it's okay because my projector is not great, but your screens might be a lot better. So the other way that we could write the x-intercepts, because again they are points, we could write them as points. So -8, 0, and this one would be 4, 0. Now in terms of your handout for today, I'm just going to open it up here. Okay, so we haven't got to this part yet. This is just an intro piece, so don't worry, you're just watching and following along so far. And the last thing, the zeros. The zeros are the exact same as the x-intercept. It's just another word for it. And once I put those in, I'll explain why it's a different word for the same thing. So these points, these x-intercepts, are also called zeros because if you look at the y values, they're 0. So these are the zeros. This is where y is 0. You can see in each point y is 0. Okay, so the x-intercepts or zeros are the same thing. Now we're going to be on the part that you have in the note, and we are going to write this stuff out together. Okay, so first, the vertex of a parabola is the point where the parabola changes direction, the top or bottom. Okay, I'm just trying to word this as simply as possible. I'm not going to test you on the definitions. The minimum or maximum point, that's going to be the y value of the vertex. Okay, can be a max or a min. The axis of symmetry, this is the x. Ooh. This is the x value of the vertex, and this is where the parabola is divided in two, like a mirror. Okay? Alright, the y-intercept, this is where the graph crosses the y-axis. I'm going to say x is 0 here. And the x-intercepts is going to be where the graph crosses the x-axis. And remember, you can pause the video. You don't have to keep up with my pace. So where the graph crosses the x-axis, and I'm going to say y is 0 here. I'm going to spell here correctly. And then for the last one here, the zeros, same as x-intercepts. Okay, now let's go up here to how do you label it. The vertex gets labeled in brackets with an x and a y value. You put in the actual numbers, of course. The y value of the vertex, or the max min, is going to be y equals the number, okay, not a hashtag. The axis of symmetry is going to be x equals a number. The y-intercept is going to be y equals a number, or we would write 0, comma, the number. And again, if this doesn't make sense, don't worry. The examples should really help. Where the graph crosses the x-axis, the x-intercepts will be x equals a number, and that'll be x, sorry, the number, comma, 0 for each one, and the zeros are going to be the same. So again, if you haven't followed along yet, that's okay. The examples are really where it's going to count, and they are on the next page of your handout. And here is the first one. Okay, so you can pause and try this one if you want. It is the first example, so you might want to follow along with me. So I'm going to go ahead and do that. So first, the vertex, right here. So there it is. It's that point, and we're going to label it down in this table. So the vertex is going to be x, which is 4, and then the y value of the vertex is -9. Okay, the max or min value I'll do in blue, and that's right along here, right? It's that y value, and we can see that it's y equals -9. The axis of symmetry is going to be another dotted line that goes straight up and down through the vertex. Both of these go through the vertex, you can see, and that's going to be x equals 4. Remember the max min. Oh, and by the way, this is a minimum value. You can see it's the lowest the parabola goes. Okay. The y-intercept, that's where the line crosses the y-axis. So it looks like it's about here. That looks like 7 to me, so we can say y equals 7, or we can write it as 0, 7. Okay, now the x-intercepts I will do in pink. The x-intercepts, or the zeros, are here and here. Okay, and they are going to be x equals 1, that's 1, and 7. So I write the word and just so I make it clear. Or we could say 1, 0, and 7, 0. And that's it. Honestly, this is all your homework's going to be. I'm going to do one more example with you. You might be wondering, why didn't you put in the information for the zeros? Well, it's the same. So it's the exact same as the x-intercepts. So basically, those are the same answers. I'm just trying to get you used to the different terms that you're going to hear. Okay, one more example from me, and then you've got 2 for practice for homework. The lesson will be about 20 minutes, and it'll probably take you 10 or 15 minutes to do it. So I'm trying not to go over my hour of time, because I know some people will take a little longer. All right, feel free to pause it and try this. If you're going to pause it and try it, pause it now. All right, here I go. The vertex, right here. The x value is 6. The y value is -3. the max or min. This time you can see this is actually the highest it goes. So this is going to be a max, and it's y equals -3. This problem never goes above -3. For the axis of symmetry, we draw the dotted line through the vertex the best I can, and that's going to be x equals 6. The y-intercept is right here, and it's y equals -12, or I would write 0, -12. Now this next one might have stumped you if you tried it on your own, and that is the zeros. So that's where it crosses the x-axis. But it doesn't. So we say none. No x-intercepts. No zeros. And we're done. Sometimes these parabolas, you'll see this more and more as we move on. Sometimes they never cross the x-axis, but I will tell you they always cross the y-axis. So sometimes you won't have an answer for x-intercepts or zeros. You'll always have an answer for everything else. Okay, last thing is 2 practice questions on the paper that I put online. Again, if you need to do it on separate paper, that's okay. If you do it in your head and then check with me, I mean, whatever works. I do encourage you to try to write it down just so you have a record of what you've done. And again, I will post the solutions to these 2 questions at 3 o'clock this afternoon. Okay, thanks folks. Good luck.